Today we're going to talk about changing receptacles. Perhaps you have the older ungrounded receptacles, the two-prong receptacles that are known as triplex receptacles. This one here has all three sections that are hot. This one here has a red dot indicating that this one right here is a switched receptacle. The difference is that there is no connection between these two screws. This one, there's that metal bar that connects both halves. If you wanted to change to the three-prong receptacles, you would check to make sure that you have a ground. And the way that you check for a ground would be to use a tester like this, and the smaller slot should be the hot conductor. So you would test to make sure that you have power at this receptacle, and if you do have power between the smaller hot slot and the plate screw, you should get a reading indicating that it is grounded. And by that I mean, and I'll demonstrate that here on one that is grounded. You'll see the needle deflect way to the right. Okay, the smaller slot here is the hot one, and if I touch that to the metal, you can see that I'm also getting a full scale reading indicating that it is grounded. In most cases, if you have receptacles and home wiring that was done with what is known as BX cable, it's an armored cable, type AC cable, armor clad. The metal of the cable shield and the box are connected by clamps. And that makes the ground continuous from outlet to outlet all the way back to the breaker box or fuse box. Before you start working in any box, you should make sure that the power is off. And the easiest way that I have found is to use what we call a non-contact voltage tester. And all you have to do is have it in close proximity to an energized conductor. This one is not energized, that's the grounded conductor. It senses the electrical field around the energized or hot conductor. So when you turn off the power to the receptacle, also make sure that there are no other conductors in that box that are energized. In some cases, the white conductor, their neutral or grounded conductor, is shared by more than one circuit. And you don't want to get in between that by opening it up and getting a shock. There are generally two grades of receptacles. This one is referred to as residential grade or resi grade, and I have part of it cut away. As you see on the back here, there are little slots to release any wire that would be put in here to be connected to the receptacle. Never use these back wire terminals. It's a little spring clip that you push the wire in, and this little clip holds it in place. It makes very poor contact. So always use the screw terminals if you use these inexpensive receptacles. Generally they're 50 cents or less each. Then we have what are known as specification grade receptacles, commonly referred to as spec grade. And usually it will even say that right on the strap of the device. Now this is a self-grounding receptacle, and that feature is evident here. This strap firmly connects this screw to the receptacle so that when it screws to the box, this strap and the third prong are grounded to the metal of the box. The other end of the device just has a little plastic tab that keeps the screw captive. it does not ground the box. If you notice, the inexpensive residential grade receptacles do not have that self-grounding feature, and then you should be running a wire from the green screw to the back of the box with a 1032 grounding screw. Now, the specification grade devices have back wiring terminals also, but the difference is that there's a little metal plate, not a spring clip. As you tighten the screw, when you put the wire in here, tighten the screw down, it makes very good contact. And I've taken this one apart just to show you that as you put the wires in and you tighten the screw, it makes every bit as good a contact from the back as it does from the side, because essentially they're one and the same. This happens to be a 20 amp configuration receptacle. The difference is the horizontal slot on the neutral. So it will accept the 20 amp 120 volt plug, or it will be backwardly compatible with the 15 amp. When you get to the 20 amp receptacles, you will notice that there is no push-in feature for the spring clip device. They are not permitted. When you wire receptacles, if you don't use specification grade receptacles, and even if you do, it's still advisable to pigtail the device. And what I mean by pigtail is one wire comes in, one wire goes out, one wire goes to the device. If the device fails, only that device fails. If you use the receptacle as a splicing mechanism, if the device fails, the rest of the circuit is affected. One of the compelling reasons to not use the spring clips is the damage that results by using them. Here's an example of a receptacle that I saw on a wall at a house when the receptacle wasn't working. When I took the cover plate off, this is what was behind it. And if you take this cover plate off, this is what was behind that. And some of the connections are obvious that they use the back wiring terminals. Don't do it. Here's another example. And this wasn't on the hot wire side, this was on the white wire side. And you can see that that is totally gone. The owner told me it was glowing red when he discovered it. And here's yet another ugly example of that. In this particular case, the wire was under the screw, but it was not tightened down properly. If you have a two-prong receptacle and you discover that you do have no ground, at the very end when you put in a tester like this and it says no ground or open ground, and you have the metal clad cable, the only other choice you would have would be to use a GFI receptacle. GFI receptacles are permitted on ungrounded wiring systems. The GFI has a test and reset button. And if that's the case, that there is no ground, then the cover plate should be labeled no ground. GFI outlets will be covered in deeper ways when we get to the GFI receptacles and how they can and cannot be used. If you have loose receptacles, here's another example of what can result. This was a surge arrestor that was in an office, and the connections to the outlets were bad, like the ones I just showed you. Here's an example of what it did to the surge suppressor. Unfortunately, it also took out two computers and was a very expensive occurrence to have. You can see more at sparkyjohn.com. SparkyJohn.com.